Video 50, Angles and Angle Pairs. Let's start by identifying some angles. All right. This angle is greater than 90 degrees. Any angle that's greater than 90 degrees we call obtuse. So this would be an obtuse angle. All right. This is a straight angle because it forms a straight line, and it is actually 180 degrees. This angle here is less than 90 degrees, and we call it acute angle. And last is what we call an upright angle, and it's usually shown by the little box in the corner that shows it's a 90-degree angle. And we call it a right angle. So there are four types of angles. There's obtuse, straight, acute, and right. All right. Now let's think about a couple of other definitions. One is complementary, right? When you create or have complementary angles, let's create one here. Right here we have one angle, and then we're going to create another one here. And these two angles together, when you add them together, form a right angle. And we call these complementary. So for example, let's say this angle's 30 degrees, and this angle's 60 degrees. If I add 30 plus 60, I get 90 degrees. And we call that complementary. A complementary angle is when the sum of two angles measure 90 degrees. That would be the example there. All right? All right, supplementary is different. Supplementary is when I have an angle here, and let's say this angle is this, and then we have another angle attached to that angle. It goes like this. All right. Let's say this angle's 45 degrees, and this angle's 135 degrees. If I add these two angles together, 45 plus 135, I get 180 degrees, right? When two angles add up to 280 degrees, they're called supplementary. So these two angles are called supplementary, and these two angles are called complementary. 90, 180. All right, let's apply this. Let's say we want to find an angle that is complementary and supplementary to a 63-degree angle. All right, so let's write a math problem. All right, let's start with a complementary angle. Okay, well, we know that it has to add up to 90 degrees. So we're going to take 90 degrees and subtract it from it 63 degrees. If we subtract 63 degrees from 90 degrees, we'll get 27 degrees. So an angle, or the measure of an angle that is 27 degrees, would be complementary to an angle that's 63 degrees. Right? Now it also asked us to find an angle that's supplementary. Okay, well, if it's supplementary, then they need to add up to 83 degrees, or 180 degrees. So if I take 180 degrees and I subtract from it 63 degrees, I get 117 degrees. So that means the measure of an angle that is 117 degrees added to an angle that's 63 degrees would give me 180 degrees, which means that they're supplementary, that pair of angles. All right. Here's another example. Okay. It says the angle between the shaft of the golf club and the golf club face is called the loft angle. All right. The diagram shows a club with a 40-degree loft angle. So we're talking right here. What is the value of x? Okay. Well, if you notice here, the two angles form a right angle. All right. So if I take 90 degrees and I subtract from it the loft angle of 40 degrees, I get 50 degrees. Okay. Another way to look at that is 40 degrees plus x equals 90 degrees. Right? If I undo the addition and subtract 40 from both sides, I would get x equals 50 degrees. So both of these strategies help me find the angle for x right here. Actually, it goes all the way up here. Alright, so let's look at another example. Okay, we have a hanger here. The sides of a coat hanger form a 25-degree angle. What is the value of y? Okay, so we have our angle here, which is 25 degrees, and they want to know what this is. Well, notice the two angles together form a 180-degree angle. So if I take 25 degrees and I add y to it, I'm going to get 180 degrees. All right. Again, I can undo my addition by subtracting. All right. Over here, I'm left with y. And over here, I'm left with 155 degrees. So y's angle is 155 degrees. Right, the second part of this video is about angle pairs. So let's look and define some of the terms that have to do with angle pairs. Right? I'm going to start by drawing two lines. Okay? So here's one line. And let's call this line A. And then I'm going to draw another line. And I'm going to call this line line B. Alright, so let's reduce the size of this so we can see the whole thing. Okay, so now I have line A and line B. Alright, I'm going to number my angles 1, 2, 3, and 4. And we're going to start to identify the different types of angles here. Let's start with adjacent angles. Okay, adjacent angles are two angles that share a common side and a vertex and do not overlap. Alright, so for instance, angle 1 and angle 2 would be considered adjacent angles because they share this side, okay, and they share this vertex. Alright, so angle 1 and angle 2 would be considered adjacent. So let's write those up here. Angle 1 and angle 2. Now if you look at the diagram, there are other angles that are also adjacent. Angle 2 is also adjacent to angle 3. So I could say angle 2 and angle 3 are also adjacent, as well as angle 3 and angle 4 and angle 4 and angle 1. So as long as they share a line, like 4 and 1 share this line right here, they're considered adjacent. Alright, vertical angles when two lines meet at a point, the angles that are opposite each other are called vertical angles. So angle 4 and angle 2 would be considered vertical angles. Alright, so for this one, we're going to say angle 2 and angle 4. Alright, Well, there are two others as well. Angle 1 and angle 3 are also vertical angles. So I'm going to say angle 1 and angle 3 are also vertical angles. Alright? Congruent angles are angles that have the same measure. Alright? Well, in this situation, if I look at angle 2 and angle 3, notice they form a 180-degree angle, right? Alright? Well, what's also interesting is if I take angle 2 and angle 1, they also form a 180-degree angle. Alright? That means that angle 1 and angle 3 are what we call congruent, because both of those angles form a 180-degree or have a supplementary relationship with angle 2. So angle 3 and angle 1 must be equal. Okay? Also, angle 2 and angle 4 are also congruent because they have the same relationship with angle 3 and angle 1, which makes them supplementary. So congruent angles have an equal number of degrees. Alright? Now, parallel lines are two lines that never cross. So here's an example of a set of parallel lines. Now, parallel lines are usually shown like this. Okay? This shows that these two lines are parallel. That's a way to notate it or show it. Alright? Intersecting lines would be like line A and B. Alright? Intersecting lines, they meet at a point. So for here, this would be the point where A and B meet. Perpendicular lines have another unique relationship. So let's make two perpendicular lines. So here's one line, and here's the other line. And they're perpendicular because they form right angles. Okay? So, perpendicular lines intersect and form four right angles. So these two lines intersect and they also form 90-degree angles. So all of these angles are 90 degrees. Now, corresponding angles are a little bit different. They involve, I'm going to draw two parallel lines here. Okay. And then I'm going to draw a line that transects it, or crosses both of the parallel lines. Alright? And then I'm going to label my angles. So 1, 2, 3, 4, and then 5, 6, 7, 8. Alright? So let's label these lines. Let's call this A, B, and C. So each of these lines has a name. Alright? If I look at the relationship between line A and line C, angle 1 sits on the top left. So it sits right here, okay? If I look at that same angle for the relationship between line C and line B, angle 5 is in that same position. It's on the top left. So angle 1 and angle 5 would be corresponding angles. Alright? Let's find the angle that's corresponding to angle 2. Alright? It's on the top right of line A in relationship to line C. Let's look at line B. What's on the top right of angle B in relationship to line C? Well, that would be 6. Alright? Angle 4 is corresponding to angle 8. And angle 3 is corresponding to angle 7. They sit in the same place. They have the same relationship. Okay? So angles that occupy corresponding positions when line intersects two other lines are called corresponding angles. And that's what we've identified here. Alright? All right, let's do this first problem. It says identify the adjacent angles.